Hello students, we are going to discuss today limit, one of the major portion from calculus session. So let me explain one by one what are the basic concept of limit. So normally we will discuss the function y equal to fx is given. In this situation, you know that this x belongs to the domain of that function only. Domain of that function. Whenever x is approaching to a, x approaching to a, we will denote this by x approaching to a. Now, what is happening here? This a may be in the domain of f, or this a may not be in the domain of f. There are two cases will arise. Either a belongs to domain of the function, or a not belongs to the domain of the function. Example, whenever x is approaching to 2, x approaching to 2, I am taking fx equal to some x plus 4. So x is approaching to 2 means this x never become 2, but its approximate value is around 2. That is the meaning of this. X equal to 1.99 or x may be 2.01. This is the situation whenever x is approaching to 2. So 2 is maybe in here in this situation, you can see that the 2 is in the domain of this function. 2 is in the domain of this function. That is very clear. Now, what is happening? X is approaching to 2. X plus 4 is approaching to. You can see that there are two cases are coming. Either 5.99 or x plus 4 is approaching to. 5.99 means whenever we are taking this x equal to 1.99 something. If x taking 2 points, then it becomes 0.01. Sorry, 6.01. 5.99 or 6.01. In both the cases, this both are approaching to 6 only. That is the things we want to learn from this. 5.99 or 6.01. In both the cases, this will be approaching to 6.2. So what is the meaning of this? From this, we will get it like this. X is approaching to 2. X is approaching to 2. You can check it. Now, x plus 4 is approaching to 6. This is the things. This is going to 6 only. Then 5.99 approximate value is coming out be 6. This we already studied in our earlier school days. 5.99 approximate value is coming out be 6. 6.01 approximate value is 6. That we know that. So this limiting value, this approximate value or limiting value is fixed actually. This way we can define the limit of a function. So let me tell you, limit of a function. Somebody will again getting confusing what is happening there, how we got it 6. Let me explain with a small example that we earlier done it in our school days. 1 by 3 is, we know that 0.333333 something. So if you cross multiply with that 3, this becomes 0.99999 something. So from this, you can see that this 0.999 something, it is approaching to 1 only, or its actual value is coming out be 1. That way we can discuss. So x approaching to 2 means x may be from the left side also, or from right side also we can explain this part. So what I am saying, limit is a small section only, but that basic concept we want to study. X tending to 2 means there are two parties coming. One is that x may be from the left side. Left value become x approaching to 2. Left value is this 1.9. So what is the right value whenever x approaching to 2? Whenever x approaching to 2, the right value is coming out be 2.01. So one thing is very clear. Whenever x is approaching to 2, x may not take that the value 2. X may not take the value 2. This is the things we should learn from this basic idea. So, and one more thing is there. If x is approaching to 2 means, you remember this x value is coming out be like this. X is tending to 2 only. That is the meaning of that. Or let me tell you, whenever x is approaching to 0, x approaching to 0 means, you should remember what is happening, that x is approaching to 0 only. This is the way we can learn that concept. X never becomes 0. That is the things you remember this. X never becomes 0, but x is approximately equal to 0. That is the things you should remember. X is approximately equal to 0. So very basic concept only. Now, in the earlier example, what we discussed, that x tending to 2, x square, x plus 4. Now, x is tending to 2, that x is in the domain of the function. But in some cases, like this, whenever we consider a function like this, let me write an example. This fx equal to, if I am taking x square minus 4 dividing by x minus 2, very clear that x not in the x not equal to 2, or 2 is not in the domain of that function. Then what will happening? X approaching to 2, what is the value of fx? That is the concern here. So we want to check, whenever x approaching to 2, where will be that graph will move. That is the main concern of limit. The graphical value, or x approaching to 2, what is the value of, or where the graph will lies. That way we can explain this one. So here you can see that 2 is not in the domain of the function. Or we can see that one thing is very clear. X tending to 2 means, one thing is very clear to this concept. X never become 2. That should be there. X never become 2. So what will happening whenever x approaching to 2, you can see that x approaching to 2, fx is coming out b. Fx is coming out b like this. Fx is tending to, this is also tending to 0, and the denominator also tending to 0. This is the things you should remember from this concept. Fx is tending to 0, and in denominator also tending to 0, numerator also tending to 0. This you should remember. So let me explain the basic part of, or let me tell you the definition of the limit. Let me explain that definition itself. So let me write it. This is the way. As x approaching to a, in bracket I can write it like this. Fx is approaching to, fx approaches to, unique means, we know that exactly one value. Exactly one. Unique means exactly one. Fx approaches to a unique value L. Then L is called, this L is called the limit of fx as x approaching to a. So we can denote this L equal to, either we can write lim means limit only, x approaching to a fx, or I can write this L equal to, in short form of limit, lt x approaching to a fx. This is the basic definition of that limit. Whenever x is approaching to a, you check it, fx is approaching to a unique value. Unique value means exactly one value is available for that. Then L is called the limit of fx as x approaching to a. These are the two notation for limit. So this is the basic definition of limit. So this is, you should remember, x is approaching to a, fx never approaching to L means limit is not existing. So there are different methods are available for finding limits. Lot of formulas and a lot of methods are available. So one by one we will discuss. So let me explain with the factorization method. That is the first thing we can easily follow. First one. Actually, we want to, in this chapter, we are going to learn different approaches to find out the limit. So all type of methods are not suitable for a simple or a single question. According to the question, we want to change the approaches. So first approach is, let me tell you, factorization method. Factorization method. Factorization. So that we know that there are two ways are there. One of them is if it is in x square minus a square form, then we can easily factorize x plus a into x minus a. This is one of the approach. Second approach is whenever in quadratic something like this, here sum of the roots x square minus alpha plus beta into x plus alpha beta. If it is in this form, let me tell you, in that situation we can write it like this, x minus alpha into x minus beta. So these are the two basic approaches. So remember, one more time, let me write it. X is approaching to a means this x need not be equal to a. So what will happen here? If x square minus a square dividing by x minus a, actually this is not 0 by 0. It is numerator approaching to 0, denominator approaching to 0. That is the meaning actually. Both values need not be 0 because x never become a. So that approach should be there. So in this situation, what we will do, this x minus a into x plus a, we can factorize like this. Here also, x minus a is coming. So what is going on here? You can check it. So what will happen now? That in numerator and denominator, one term is there, x minus a, that we will get cancelling. So these two will get cancelled. That you can easily check it. So we can cancel these two things. You know, this x minus a, I can cancel that x minus a in both numerator and denominator. X minus a I can cancel. So what we will getting, x plus a only I am getting here. So why I cancelled this? X approaching to a means x minus a never becomes 0. In numerator and denominator, this expression x minus a is not equal to 0. So that is why we are going to get cancelling these two things. So earlier I put an example like this, limit x tending to 2, x square minus 4 dividing by x minus 2. What will happening to this problem? You can check it. Here it is something like this. We can factorize this. That will coming out be x minus 2 and x, these things will coming something like this. You can easily check it, that x minus 2 into x plus 2 and the denominator also x minus 2. So x minus 2 will get cancelling. So what we will get it now, this is limit x approaching to 2, you are going to get x plus 2 only. So final answer is coming out be 4. So this way we can have this type of problem. So I explained two methods here in factorization. There are a lot of methods are there. Lot of things are in factorization. You studied earlier a chapter also. One of them is You can remember this identity: x plus a into x minus a is x square minus a square. In quadratic concept also you discussed x minus alpha into x minus beta is coming out be x square minus alpha plus beta into x plus alpha beta. So whether it is in x square minus a square or in this x minus alpha into x minus beta form, you should first calculate, or first we want to manipulate the things properly. We want to manipulation is going on for finding the limiting section. That is the most important part of this. So let me explain with another small example. You see here, let me write one example. Limit x is approaching to 1, x square minus 7x plus 10 dividing by x square minus 3x plus 2. So here x approaching to 1, this is x approaching to 2 is better, I think. X approaching to 2. Now what is happening? Numerator become 0. If you put 2, numerator becomes 0. Denominator also, you put x equal to 4 minus 6 minus 2. So this is actually, I want to write it, it is approaching to 0, and the denominator also approaching to 0. They never become 0. That should be there. But it is approaching to 2. In numerator, we can convert this. In a factorization, you know that it is x equal to 2 satisfying this. That means we can take x minus 2 is a factor. Now first term is x square. So we want to write in the second bracket x, and the last is min plus 10. So we want to keep a minus 5 here. The same situation here also. X equal to 2 satisfying means x minus 2 is a factor. It is very easy. We can keep the second bracket, first term is x, and then this is minus 1. So you can calculate, the same thing will be coming here. So here x approaching to 2 means this x minus 2, this is never become 0. That is the main concept in this. So that is why we are going to get cancelling these two terms. These two terms we are going to get cancelling here. So what will remaining the next step? X approaching to 2. I am going to get cancelling these two things only. So what is I am getting here? X minus 5 by x minus 1. Now we can check it. Denominator cannot be approaching to 0. So this is denominator is coming out with 2 minus 1. X is approaching to 2 means 2 minus 1 become 1 only. And the numerator become 1 minus 5. This is 2 minus 5. So answer is coming out be minus 3, the answer to this problem. So I explained with this basic concept of limit. Slowly we want to study one by one. Then only you can have a clarity about this. So I am telling you these things in the examination point of view only, and some of the concept we want to study it in a very proper way. So let me explain some result we want to learn, and you should remember, or this is the some of the mathematical tools we want to learn in higher studies also, and also in 12th class also we will study this. Some of them is, let me tell you, e raised to x expansion form is 1 plus x by 1 factorial, x square by 2 factorial, x cubed by 3 factorial. This way we can write e raised to x. This is called the exponential series. Exponential series. E raised to x in series form. Exponential series is this one. So advantage is that e raised to x minus 1 is, I am taking this 1 in the LHS. This by x 1 factorial is 1 only. X square by 2 factorial. X cube by 3 factorial. That way it will move. So some of the things is we are going to dividing by x. What we want to get it? LHS become e raised to x minus 1 by x. What about RHS? It is 1 plus x by 2 factorial, x square by 3 factorial. This way it will move. Now what I am going to take, x is approaching to 1, e raised to x minus 1 by x. This I am going to take it. So this is actually, if you put x equal to 0, I mean, sorry, not 1, x equal to 0. E raised to x minus 1 by x means, whenever you are putting x equal to 0, this is in 0. Numerator approaching to 0, denominator approaching to 0. This is in LHS. And what about RHS? RHS, you can see that this is 1. All other terms are moving to 0 only. So what we will get it here. The answer to this problem is e raised to x minus 1 by x is. So that way we can use this series form. So let me give a small example like this, or I can put it in a box here. You see what let me tell you. This is the situation. Whenever x approaching to 0, e raised to x minus 1 by x is coming out be 1 only. Or you can write it like this also. Whenever x approaching to 0, e raised to x minus 1 should be, approximate value should be x only. That way, how we got it this, if we cross multiply this, that become x, e raised to x minus 1. So one condition is, you should remember, this is happening whenever x is approaching to 0 only. Whenever x is approaching to 0, e raised to x minus 1 is tending to x. So that things you should remember. So let me explain with one more series form only. So series form of different functions are available. For this sake of doing this limit, you should just by heart this series form of sin x also. So once you will be thoroughly clear with the concept of calculus, you can go through the series form also. Maclaurin and Taylor series, these two people are given more clarity about this type of series, but we don't want to learn that things. We want to study some of the mathematical tools like this. Sin x is x minus x cube by 3 factorial. Alternate plus minus is coming. If you going to divide sin x by x, you see what is happening. If I am going to dividing by sin x by x, this first term is 1. All other terms containing that x square and higher powers of x square. This way it is moving. So this is the way it is going. Now I am going to take the limit x tending to 0. Sin x by x. Now LHS, what is happening? Numerator tending to 0. Denominator also tending to 0. That is happening. X never becomes 0. That you have to keep it in these things in your mind. This sin x by x, that x tending to 0 means sin 0. We know that sin 0 is also 0. So sin x, this is what is happening. The LHS is coming out be sin x by x. In RHS, you can check that value. What is happening whenever sin x, it is coming out be 1 only we are getting. So sin x by x is coming out be 1. So answer to this is this one. Or let me put it in a box like this. The two result I told you. One of them is that's e raised to x minus 1 by x. So these things we want to study it very properly. First one is limit x tending to 0, or latest one is sin x by x is 1, and earlier I have written like this, sin x by x1. Earlier I have written this is 0 only, x approaching to 0, e raised to x minus 1 by x. This is also equal to 1. This is also equal to 1. So, or we can say like this, whenever x is approaching to 0, sin x is, we can replace it with that x also. So this is one of the situation we will use this. Now other complicated cases also coming later stage. That time we will give some more ideas. Now just you should remember this one, sin x by x tending to x whenever x approaching to 0, and e raised to x minus 1 is tending to. So this way we have to remember. So sin theta. So from this we are getting lot of other result also. For example, let me tell you, if x tending to 0, 2x, 3x, 4x, all these values are tending to 0. So we know that sin x should be tending to x, or sin 2x. This is the situation. Whenever x tending to 0, that situation, you can see that whenever sin x is x tending to 0, then sin x is approaching to x. Then what about sin 2x? It will approaching to 2x. Now sin 3x will be approaching to 3x, or sin kx will be approaching to kx. This way we can simplify this type of limiting questions. So the same situation, let me tell you. Now there is no need of series form. Let me tell you, in cos x, what will happening whenever x is approaching to 0? That is 1 only. So what is the meaning of this? Whenever x is approaching to 0, cos x can replace it with 1. That is the things you should get it from here. Now, same situation for tan x also. So whenever limit x tending to 0, tan x is what is happening? This is tan x, we know that is sin x by cos x only. So what is happening to that? Numerator tending to x, denominator tending to 1. So this is the way we are getting. Numerator tending to x, denominator tending to 1. These things we are getting it from this. So what is the meaning of all these concepts? You see, let me put it in some box. What the things we got it now? These are the basic ideas you should remember. Whenever x is approaching to 0, that is the major part of this. Sin kx should be tending to kx only. Cos kx should be 1 only, you will get it. Tan kx should be kx only there. Cot kx should be 1 by tan x is cot. Na? So tan kx is approximately equal to kx. In that situation, cot kx, what will happen in cot kx? It is 1 by tan kx only. So this value is coming out be 1 by tan x, and e raised to x minus 1 is approximately equal to x. These are the things I told you now. So please go through each and everything one by one very properly. Let me explain a small example. You see, let me give you some questions like this. Limit x approaching to 0, x cot 4x, x cot 4x dividing by x approaching to 0 only, sin square x into cot square 2x, cot square 2x, sin square 2x into cot square 2x, cot square 2x only, 2x. So in the last session, I discussed something like this. And what about sin square kx or sin square x? Whenever x tending to 0, what I said first, sin x is tending to x. Then what about sin square x? Sin square x is sin x the whole square only. So this will approaching to x square. That also you should remember. So let me explain this with a small example. Whenever x approaching to 0, x is approaching to 0, what is happening? This cot 4x is approximately equal to 1 by 4x, sin square x tending to x square, and cot square 2x tending to 1 by 2x the whole square. These are the things we got it from here. So what will be that left hand side? What will be the left hand side? Limit x is tending to 0, numerator is x, instead of cot 4x, let me write 1 by 4x, and in denominator sin square x I can write x square, and cot square 2x, what I can write it 1 by 2x the whole square. So you see what the things I am getting, numerator 1 by 4, denominator also 1 by 4. So answer is coming out be 1. So this way we can solve this. So it is very easy approach. So this is the basic idea of limit. In the first lecture, I done some of the basic concept. You should remember this, how I done this problem. So go through one by one. Let me explain. These are the extending to 0 case. Sin x is approaching to x, sin kx is approaching to kx, cos kx approaching to 1, tan kx is kx only. Approximately value I am telling you. Cot kx is 1 by tan kx, so it is 1 by kx. E raised to x minus 1 by, that is approaching to x. Sin square x equal to x square. So you should go through all the things. These are the things we discussed: factorization method, and some of the definition like this. X is approaching to a means x never become a. That is the things I want to tell you. And I hope you got all these things. uh, so we will discuss the next concept in the next part only. So if you have any doubt, please try to contact me. I can give you my number also in the next lecture part. So you can have your suggestions and any doubts, please try to contact me. So I am stopping. Thank you. Thank you for watching this.